For more than a century, steel has been the hidden force behind global power. Every modern nation that rose to industrial dominance did it on the back of steel production. From massive bridges and skyscrapers to warships, railroads, and automobiles, steel became the material that shaped the modern world. Countries like the United States, Germany, and the United Kingdom once controlled this industry so completely that their factories essentially dictated the pace of global manufacturing. But something dramatic has changed over the last 2 decades. A new industrial giant has completely rewritten the balance of power, and most people still do not realize how far ahead it has moved. In 2025 alone, China produced more than 960 million metric tons of steel. That single number is difficult to fully understand because it is larger than the combined output of most industrial nations on Earth. The United States, by comparison, produced roughly 80 million metric tons during the same period. That means China made more than 12 times as much steel as America in 1 year, and the gap is growing. But this story is not only about quantity. Producing huge amounts of steel is impressive, but volume alone does not guarantee technological leadership. History has shown that the country producing the most products is not always the country producing the most advanced products. What makes this moment different is that China is not simply flooding the world with cheap steel. It is building a new generation of steel that many Western factories struggle to manufacture competitively. The material itself has evolved, and China has positioned itself at the center of that transformation. Most people think steel is a simple material, heavy, strong, metallic. But in reality, steel is an enormous family of engineered materials with completely different properties depending on how they are designed and processed. Some forms of steel are built for toughness. Others are designed for flexibility, corrosion resistance, or extreme heat tolerance. The newest category attracting global attention is called advanced high-strength steel, particularly what engineers refer to as third-generation grades. That may sound technical, but the idea behind it is surprisingly simple. Traditional strong steel usually comes with a major weakness. The harder and stronger it becomes, the more difficult it is to shape. Manufacturers have spent decades dealing with this compromise. Softer steel can easily bend into complex forms, but it lacks strength. Strong steel can survive intense stress, but shaping it often causes cracks and fractures. Third-generation advanced high-strength steel changes that equation. Engineers manipulate the internal structure of the metal at microscopic levels, carefully controlling crystal phases and atomic arrangements to create steel that is both extremely strong and highly formable at the same time. In practical terms, it means manufacturers can stamp lightweight components into complicated shapes without sacrificing durability. That breakthrough matters far more than most people realize. Take electric vehicles as an example. Every kilogram removed from a vehicle increases efficiency and driving range. Car makers around the world are desperate to build lighter vehicles without compromising safety. Advanced high-strength steel allows them to reduce weight dramatically while improving crash protection. Several automakers have already reported major improvements after adopting these materials. Vehicle frames and structural components built with newer steel grades have reduced body weight by over 25% in some models. Floor structures, side panels, and reinforcement beams are becoming significantly lighter while remaining stronger than older designs. That means better fuel economy, longer battery range, and lower manufacturing costs. And unlike expensive materials such as carbon fiber, advanced high-strength steel can often be integrated into existing production systems without requiring entirely new factories. That last point is critical. A manufacturer does not necessarily need to redesign its entire assembly process to use these materials. It simply needs reliable access to the steel itself. Right now, China dominates that supply. Chinese steel producers have managed to manufacture advanced high-strength steel at prices many Western producers struggle to match. Reports across the industry show Chinese suppliers consistently offering these materials at significantly lower prices than competitors in Europe and North America. For procurement managers inside automotive companies, the decision is increasingly mathematical rather than political. When one supplier delivers comparable material at substantially lower cost, pressure builds quickly to shift purchasing decisions. And this issue extends far beyond cars. Modern infrastructure projects rely heavily on lightweight, high-strength materials. Bridges, rail systems, energy pipelines, wind turbines, and industrial machinery all benefit from stronger steel with reduced mass. Defense industries also depend on advanced steel grades for military vehicles, naval construction, and protective systems where durability and weight are equally important. In every sector where strength, safety, and efficiency matter simultaneously, advanced steel becomes a strategic advantage. This is where the deeper problem emerges for Western economies. Many steel mills in the United States and Europe were built decades ago around older manufacturing systems. A large portion still relies heavily on traditional blast furnace technology designed during a completely different industrial era. These facilities were optimized for large-scale conventional steel production, not the highly precise thermal and chemical control needed for newer steel grades. Upgrading them is incredibly expensive. Constructing a modern advanced steel production line can cost hundreds of millions of dollars before a single ton of steel is produced. Full modernization projects often run into the billions. Companies attempting these upgrades also face temporary shutdowns, operational disruption, and uncertain returns on investment. At the same time, they must compete against Chinese manufacturers that already possess large-scale production capacity and lower operating costs. That creates a dangerous cycle. Private investors hesitate to fund enormous modernization projects because Chinese competitors can often undercut prices before the new facilities even begin operating. As a result, many expansion plans in Europe and North America have slowed or stalled. Several major Western steel companies have openly acknowledged delays in advanced steel investments due to financial pressure and uncertainty about long-term competitiveness. Meanwhile, China has approached the industry with a completely different strategy. Instead of relying entirely on market forces, Beijing has treated steel modernization as a national industrial priority. Over recent years, China launched enormous state-backed investment programs focused on upgrading steel production, reducing emissions, and expanding next-generation manufacturing capacity. One of the most ambitious areas involves hydrogen-based steelmaking. Traditional steel production depends heavily on coal, making it one of the world's largest industrial sources of carbon emissions. Hydrogen-based systems aim to replace coal with hydrogen fuel during key stages of iron reduction. The process dramatically lowers carbon output while creating cleaner production conditions for specialty steel manufacturing. China has invested billions into pilot projects in industrial-scale hydrogen steel facilities across multiple provinces. These projects are not small laboratory experiments. Some are designed to produce millions of tons annually using green hydrogen and advanced electric furnace systems. At the same time, China is aggressively expanding electric arc furnace capacity. Electric arc furnaces offer greater flexibility than traditional blast furnaces. They can switch between steel grades more efficiently, operate with cleaner energy sources, and better support the production requirements of advanced high-strength steel. China's long-term industrial planning combines infrastructure spending, research partnerships, workforce training, and supply chain control into a single coordinated strategy. And there is another layer to this story that could reshape global trade entirely. Governments in Europe are introducing carbon border taxes designed to penalize imports produced with high emissions. Under these rules, steel manufactured using older coal-heavy methods may face additional costs when entering European markets. China appears to be preparing for that future in advance. If Chinese manufacturers can produce cleaner steel through hydrogen systems and electric arc furnaces at industrial scale, they may avoid many of those penalties while older Western facilities continue facing higher carbon-related costs. In other words, China is not only competing on price and scale, it is preparing to compete on environmental compliance as well. Then there is the supply chain issue. Producing advanced steel requires more than iron ore and coal. Many high-performance grades depend on specialized alloying elements such as niobium, manganese, and vanadium. These materials strengthen the steel and help create the microscopic structures responsible for its unique properties. China controls a massive share of global refining and processing capacity for several of these critical materials. That means even if Western countries rapidly built new steel plants tomorrow, many would still depend on Chinese-controlled supply chains for key industrial inputs. This advantage did not appear overnight. For years, China invested heavily in mining partnerships, refining infrastructure, logistics networks, and strategic resource acquisition around the world. While much of the world focused on short-term manufacturing economics, China built long-term industrial ecosystems. The knowledge gap is becoming equally important. Patent filings related to advanced metallurgy, hydrogen steel making, and high-strength steel chemistry have increased sharply from Chinese institutions and companies over the past decade. Patents matter because they represent proprietary production methods, engineering expertise, and manufacturing processes that competitors cannot easily replicate. When one country develops dominant expertise in an emerging industrial technology, catching up becomes far more difficult than simply purchasing new machinery. Experience, research talent, and process optimization accumulate over time. China is also expanding manufacturing influence beyond its own borders. Chinese-backed steel projects are appearing across Southeast Asia, the Middle East, and parts of Africa. These facilities often use Chinese technology, Chinese engineering systems, and Chinese industrial financing. That allows production to move closer to international markets while reducing exposure to tariffs and trade restrictions aimed directly at Chinese exports. As global demand for advanced high-strength steel continues growing, these overseas manufacturing networks may become increasingly important. The broader implications are enormous. By the end of this decade, many industries could become deeply dependent on supply chains tied directly or indirectly to Chinese industrial infrastructure. Automotive manufacturing, clean energy systems, construction, transportation, and defense production may all rely heavily on access to advanced steel materials. For Western governments, this raises difficult strategic questions. If critical industrial materials are controlled largely by one country, economic vulnerability increases during trade disputes, political tensions, or supply disruptions. Dependence on foreign manufacturing is manageable for simple consumer goods. It becomes much more serious when it involves materials essential to national infrastructure and defense. Some governments have started responding with subsidies, tariffs, domestic investment programs, and industrial policy reforms aimed at rebuilding manufacturing capacity. But rebuilding a competitive industrial base is not something that happens quickly. Steel plants take years to design and construct. Supply chains require long-term coordination. Skilled metallurgical expertise cannot be developed overnight. Research ecosystems take decades to mature. Meanwhile, China continues moving forward at full speed. Every year of additional investment expands its technological lead, strengthens global customer relationships, and deepens control over the industrial systems supporting future manufacturing. The most important lesson in all of this is that industrial dominance rarely happens by accident. China's position was built through deliberate planning, massive capital investment, coordinated policy, infrastructure expansion, research development, and long-term strategic thinking. The world is entering a period where advanced materials may shape global power as much as oil, computing, or energy once did. Steel itself is evolving from a basic industrial commodity into a highly engineered technology platform. The next generation of vehicles, buildings, transportation systems, and energy infrastructure will depend on materials that are lighter, stronger, cleaner, and more efficient than anything widely used before. And at this moment, China appears to hold the strongest position in that race. The question now is whether other nations can close the gap before the industrial landscape becomes permanently reorganized around a new center of manufacturing power. Because the steel defining the future is no longer the same material that built the last century. It is smarter, cleaner, more complex, and strategically more important than ever before.